Yeah, I'm Brad, Go team. I'm in the process of moving back to Seattle right now, so I'm glad to be back. I stole all these slides from this guy, Taichi Nakashima, yay open source. But he kind of stole them from somebody else. But the whole point of this is they had this kind of Go 1.6 release party thing where it was kind of a global party to celebrate 1.6, and everyone kind of made slides and collaborated on slides for these release parties. So this has kind of become a tradition to have a Go 1.x release party presentation and drinking, I guess. So he stole these slides, and he stole them from the design doc. But this is, yeah, I'm going to basically summarize what happened in the last release, and then we can kind of be informal and do questions and stuff. But as a bit of a history of Go kind of began in early 2008, kind of some brainstorming. It kind of became a thing over the next year and a half, and it was open sourced at the end of 2009. And then between the end of 2009 and the beginning of 2012 was kind of a bunch of weekly releases, and basically everything would change and break every week. And there was no Go tool, there was like make files and stuff. And it was kind of painful and kind of exciting, I guess. Then Go 1 came in the beginning of 2012, and with it came the compatibility promise, which some people find boring and some people find exciting, because it means you can actually build reliable systems on top of Go and know that it's not going to change on you every release. So that was kind of like the most notable release that Go 1 was, and everyone after that has been a little bit more boring and a little bit more exciting, depending on your perspective. Go 1.1 took over a year, a little bit over a year, and we decided that that was too long. It felt too long. So we went to a 6-month release cycle, and the cycle is divided in half. There's like kind of 3 months of crazy fun time where we like do risky things, and then there's 3 months of stability. And generally those first 3 months kind of have a plan, so it's not super risky, but we're not super careful either. I mean, we still write tests and all this sort of stuff, but. So Go 1.1 came out May 2013, and then we kind of did 6 months later was Go 1.2, 6 months later was Go 1.3, 6 months later was Go 1.4. These were all great releases, but they always came on summer and Christmas holidays, which was kind of annoying. So we shifted Go 1.5 to be an 8-month cycle, also because Go 1.5 was kind of a gigantic release. That was the one that Go switched to be fully bootstrapped, and it was all written in Go. So it was nice to have an extra 2 months for that to soak. Then we got back on the 6-month release train. Go 1.6 came out the beginning of this year in February. And Go 1.7 was released yesterday, exactly 6 months, pretty much exactly months after Go 1.6. So this is a talk about what kind of happened in the last 6 months. Wait, who's using Go 1.7 already? Who filed bugs against 1.7? Who's waiting until it's already shipped to file bugs against us? Because you're all slackers. This is like the story of the last 2 days. Go 1.7 has no language changes, which kind of continues the trend of every release kind of getting more boring from a language perspective. I gave a whole talk about this, about introducing Go 1.6, asymptotically approaching boring. That was kind of like, you know, if I think actually I have in here somewhere like, I lied and told people that some excitement was coming. Yeah, I had this graph of like language changes by Go version, and it's pretty much every release kind of goes down. So we're at 0 now, but it's exciting if you value stability. So in Go 1.7, normally going through our release notes, this is basically this presentation is basically a copy of the release notes in slide form. We talk about new ports. There's a port to IBM Z systems. If you have a millions of dollars laying around for a mainframe or whatever those things cost, we now run on those thingies. Plan 9 on ARM. Okay, we got one person here. And more importantly, we now run on Mac OS X, or Mac OS, not X, Sierra 10.12. They changed how they do system calls to get the time, which kind of breaks everything. If you can't get the time, nothing works. And that was kind of our fault, because we were doing raw system calls on Macs, which they say explicitly aren't supported, but we got lucky the last 4 years and they never changed anything, and they just decided to change things twice. So we actually backported the fix to Go 1.6.3 because everyone was filing bugs, and then they changed it again in macOS Sierra Beta 4. So if you update to the latest OS X, Go 1.6.3 won't even work. But Go 1.7 will for now, but we're waiting until they release the final Sierra to see if we got lucky. Tooling, so there's basically two big things in Go 1.7. The two big things are SSA, the new compiler backend, and context in the standard library. But then there's a lot of like kind of medium big things. So we'll kind of go through the medium big things. The big one is the SSA compiler. So this is a whole new backend, which is kind of like Go caught up to the early 90s on compiler technology. And we're now doing what all the textbooks teach you to do. But Go's compiler kind of predates the textbooks. And we were based originally on the old Plan 9 C compilers from Ken Thompson. And he knew that compiler originally, so he based the original Go compiler on it. And when that was converted to Go, it was basically the same code base in Go syntax. So we now kind of do what everyone else does, and we have an SSA form. And kind of briefly, this is an output from the compiler now. It has kind of a debug mode if you want to see the passes. But in SSA form, you can think of it as kind of like an assembly language with an infinite number of registers, or think of a register as a variable, but the variables are only assigned to once. They can only ever have one value. So I have this program here called dumb. And see if you could, let me make it a little bit bigger. What does this program print? Nobody? 202. So it's easy for humans to read through this and reason that all this other stuff is useless. But the old Go code wasn't as good. In the old Go compiler, one hand, you would see output like this, where you would actually see it like moving 101 into registers and moving crap around. So it couldn't really like reason about the code quite as well. It had some optimizations, but they were kind of very local. In Go 1.7, there's no more reference to 101 there. It basically puts 202 exactly where it needs to make the call to print it out, and then it's done. So there's now, we compile from the front end when we parse your program into this SSA intermediate form. And you can see things like all your variables, like in that dumb program we had 99 and 0 was implicitly initialized, and we had 101 and 102. But then there's all these passes where things get merged, and these are all like the textbook optimizations that every other compiler except for us did, and now we do too. And there's dead code and all these optimizations and lowerings and blah blah blah. And 37 passes later, you get like the actual machine code. So all of these passes are kind of defined by rules and the kind of a high level, really readable kind of syntax. So it's really easy to add optimizations now. There's been some CLs that people have submitted or changes people have submitted that have just a couple lines saying, well, if you kind of see this pattern, kind of convert it to this pattern, and it has like massive performance speed up. So once we get everything in SSA form, optimizations are now getting a hell of a lot easier. So that was the big thing. That's been in development for the last year, but it wasn't ready for 1.6. So it is now in 1.7, but only for AMD 64, so only for 64-bit x86. And for this release, and probably this release only, you can turn it off by passing -SSA 0 to the compiler, but I wouldn't depend on that. Only use that for debugging. There's also a new toolchain export format. This is the thing, if you ever look in your, in your Go path, there's like the bin directory and the source directory, and then there's that like crap directory called PKG that's just like, shouldn't exist at all. I argue that that should just be a cache somewhere on your like system caches directory. And maybe we will eventually get rid of it. But for now, all those like .a files or .o files there have a bunch of so you see all this binary crap at the top? This is all new. It used to be this kind of pseudo Go representation of like what this module exported or what this package exported. And we kind of like reread this pseudo Go code for no reason. So now we have a new file format, which is much faster for the compiler and more efficient. So that was a big performance speed up. So a lot of the compiler optimization is a result of that, and also from SSA. A lot of people worked on the linker to make the linker a lot faster. So overall, there's some graph of compilation times for some large projects. Go 1.4 is the blue one here. That was kind of the last one where the compiler and linker were still written in C. And then we did this like really gross mechanical transformation. Russ Cox wrote a program that translated our C code into really horrible Go code. And it wasn't that Go was slower, it's that the generated code was like really horrible. And it just didn't run well because the Go compiler and runtime was never kind of like optimized to run code that bad. So we got really slow, and people complained that we were slower, kind of rightfully, but we knew it was kind of like the long-term right direction to be bootstrapped, and it would lead the way to other optimizations. And we got a little faster in 1.6, and 1.7 is even faster. This is just for compilation. So we're not quite as fast as 1.4 yet, but on the linker, the linker is faster than 1.4, and this is often the long chain of your serialized dependency tree linking lots of things. So yeah, so it's a lot faster. Yesterday, happy user number 1 replied that their test suite went from 3 minutes and 34 seconds down to 1:48, and something else took 1 minute 15 seconds less. And happy user number 2 said something you can't read, but I'm assure you it's great. Look at those numbers, 1.5x, 2.2x. So yeah, people are really happy with the build times in 1.7. The other thing people are happy about is that we now include in the generated output the frame pointer, which a lot of C profiling tools kind of expect. We omitted it for performance reasons in the past, but we've gotten it to be fast enough that it's okay. And so now you can run all these kind of like Linux perf tools that generate flame graphs and like let you profile running systems without recompiling. So yeah, if you like the Linux perf tool, profiling Go tools is a lot easier. This is boring. Some syntax for the linking in. There's this thing where you can stamp a binary as you're linking it with a value. People generally put like the get commit hash linked into their binary without generating code. And it used to accept a space, and now you have to do an equal sign. Boring. The vendor stuff is now on, and there's no option to turn it off anymore. We still don't have good tooling around vendoring, but the mechanics of how it'll work once the community stops squabbling about the upper level stuff is at least fully baked in and on by default. And there are people now that are trying to talk to the community and figure out a plan. This is kind of a weird one. Go has gotten stricter over time about the Go tool when it compiles stuff, that if your source code changes at all in a directory, to automatically rebuilding your object file, or if like you delete a file, we know that your file was deleted and we rebuild it. People were kind of trying to ship binary only packages around, and a lot of times this was at universities where they wanted to like give students some program but not all of it for some reason, have them implement other parts or something. So we added this little stupid annotation saying Go binary only, and if we see that, the Go tool will trust whatever .a file is on disk and not try to rebuild things. So people freaked out a lot about this when they said, "Oh, Go's anti-open source. We're supporting binary only packages." We're not at all. We're making no effort to make these compatible from release to release. Basically, it says you now have a mechanism to live dangerously if you want to. There's some more GoVet tests if you use GoVet, which can kind of find things that are almost certainly errors, but maybe not. Things about forgetting to close cancels, which is, should be in a different order. Performance stuff. There's optimizations all over. The new compiler, the SSA backend, makes smaller binaries, but it also makes faster binaries. And on our Go 1 benchmarks, we have a suite of benchmarks we run on every release. They range from 5 to 35% faster. Some people have reported even faster for certain numerical code. And then independently, people have optimized a whole bunch of these packages. So those are around 10% or so in various packages. So it's faster across the board. The garbage collector is now a little bit better too. They worked on some of the tuning about when it does certain things at certain thresholds. Idle Go routines are not scanned, so if you have like, hundreds of thousands of idle Go routines and the garbage collection runs twice, it will not rescan the stacks of any Go routine that hasn't run since the last time the garbage collector scanned that stack. And scanning the stacks of Go routines is one of the more expensive bits. And also, they looked at the hot paths of the compiler in the garbage collector code and to see what was running all the time, and made sure that the SSA compiler, the SSA backend had optimization rules for that code, and they added compiler intrinsics for a lot of the things. So yeah, that was a bunch. It's a lot faster. So this isn't like algorithmic changes. This is just tuning stuff. There's kind of a new algorithmic overhaul coming in 1.8. Standard library stuff. The big one is context is now in the standard library. It used to be in Golang XNet context, and it got popular, and everyone started depending on it, and we wanted to use it in the standard library itself, so we kind of promoted it. There's some testing stuff and some HTTP tracing stuff. So context, well, you can read some blog posts about it, but the main things it lets you do is it lets you do timeouts, cancellation, and sending kind of a bag of data or stuff down the chain, which is kind of the part I like the least about it. The main part that is exciting is that you can do timeouts and cancellations. So you can have like a whole tree of requests outstanding across the network or whatever, and then your user goes away, and you can cancel a whole tree of stuff. So context can derive from other contexts, and if you cancel a parent one, it cancels all the children one. So you can write, on the HTTP package now has support for context, so you can both on the server side, you can get your request context, and when you're making a request, you can say request with context, and you can create your own context. You say this is a new context CTX that's derived from the background context, and this one will time out in 100 milliseconds, but I will also give you a cancel to close it earlier. So you could do this for cleanup, but if you also like get bored of this request or your user goes away, you can cancel it. And these things can all be in chains. And so here we're making a new HTTP request, which is the same as this original one, getting google.com, but with this context. So this request now will time out if the whole thing takes longer or any part of it takes longer than 100 milliseconds. You can do the same thing with the osexec package now. So if you don't want to wait for a child process to run too long, or you want to abort a child process. The testing package now has kind of support for running these sub-test marks. So you used to have to write, like, if you wanted to benchmark some function with varying sizes of buffers or something, you would basically make a little helper that took a size, and then you would write a whole bunch of little stupid wrappers that calls the original one. But now you could do a table-driven test and just say, you can make this sub-benchmark, and you basically say b.run and kind of a child name. And then the cool thing is you could still run these separately like you could before, but you don't have to write the boilerplate stuff. Yeah, you can do it for tests too, but only benchmarks are shown here. There's some people who are doing some crazy HTTP stuff that needed to have lots of detailed timing information about the lifetime of requests and when things happened. So when you make a HTTP request, do a DNS request, but your DNS request was doing, got an IPv4 and IPv6 at the same time, and then you might do the happy eyeballs where you try IPv6 first, and if that fails after a certain amount of time or doesn't do anything, then you race IPv4 and you have two dials going and you pick which one races. There's all these details that some people really care about knowing the timing info. So now there's this new package where we threw all this crap called HTTP trace. So we put it explicitly in another package so you don't have to see it if you don't care. But the people who care really care, and now there's this whole bag of hooks. So if you want to know about your whole lifetime of every possible thing that can happen during a HTTP request, there you go. And then you could trace things. Standard library, as always, was kind of touched all over the place. That happens kind of in every release, little additions, fixes, documentation stuff. The tree opened for Go 1.8 last night, and 145 commits have already gone in. People were waiting. And even while I've been sitting here, there's been another 20 or so that have gone in. So the plan in general for Go 1.8 is to do SSA for all architectures, not just AMD 64. So already, while the tree has been frozen for the last 3 months, the people hacking on SSA They finished 386. PowerPC is just about done. MIPS64 or something, or yeah, MIPS64, little endian, and ARM64, and people are talking about doing RISC-V, and someone's talking about doing Spark64. But these are all going in, and so then the plan is that we delete the old compiler backend, and once the old compiler backend is deleted, then we can make the current compiler front end no longer assume that the compiler backend is dumb, and assume that it has like a early 90s compiler, and then the compiler front end can do a hell of a lot less work, which will make the compiler front end faster, and then because it's faster and it's giving bigger chunks of work to the back end could be faster too, the SSA backend. So there's a lot of performance improvements coming in the compiler, and also they're rewriting the front end, which is just starting to land too, so with a new parser and stuff. So a lot of compiler implementations of 1.8. I have just started fighting this battle to get sort.slice in to make it easier to sort things. Don't hold your breath. We'll see. There's also this other thread. I'll maybe tweet a link or something to this so you can click things. But a whole bunch of people discussed what they want to do in 1.8 in this one thread. But we can kind of open it up to questions, or we